A very good morning to Dr. Muhammad Asmadi and all my fellow friends. We are from Group 13. First of all, I'm going to introduce my team member, Roger Warren, me, Dr. Fei, and Kibia. Our proposed chemical product is Hand Sanitizer. Product survey and business model. The global hand sanitizer market size valued at 2.7 billion in 2019 and is expected to grow at a compound annual growth rate at 2.6% from 2020 to 2027. This is due to the outbreak of COVID-19 pandemic. The most effective way to protect us from these germs and diseases is to maintain proper hand hygiene. That's why there is a market for hand sanitizer. The potential customer to buy the hand sanitizer is the healthcare service, hotel and restaurant, household purposes, and those involved in daily customer service. The functional attribute of a hand sanitizer should be able to kill 99.99% of the common germs by denaturing their protein. The logical attribute of the hand sanitizer should be convenient to spread easily on the skin, and its physical attribute should be in small bottle for one person carrier, and it must be in gel form. Sensorial attribute of the hand sanitizer should be our hand should be feel dry after rubbing for a few seconds and will feel smooth and does not cause irritation. The most important, it can keep our skin moisturized. The figure shows that the household quality of the hand sanitizer. So, the customer require the hand sanitizer should be easily evaporate, must have fragrance, antibacterial properties, should be able to protect skin from dryness, easily flow from the bottle, and easy to carry. For our design and molecular level, first of all, we should find out the mini database of the hand sanitizer. Hand sanitizer consists of alcohol, hydrogen peroxide, glycerol, and essential oil. Alcohol is to denature the protein of the lipid membrane and of the microorganism. Hydrogen peroxide is to inactivate contaminating spore. Glycerol is to function as a moisturizer, and essential oil as a antibacterial or antiseptic property and provide flavoring agent. The problem definition at molecular level is we need to find out a variety of alcohol should be determined according to the CN step. We want to find out the most suitable alcohol to be used as the active ingredient in our hand sanitizer, which can kill the germ and decrease the infectious agent on the hand. So we use the CMD method to solve the problem. By using the ICAS software, first we set up the compound should be acyclic and must only consist of alcohol, and the basic sets of groups to be generated from the alcohol must be CH3, CH2, CH, C, and OH. Later, we should set the maximum and minimum number of groups allowed in the molecule, and the minimum and maximum number of functional groups allowed in the molecule. So the diagram shows the result what we generated from the ICAS software. There are 16 chemical compounds to be generated, and I find out the molecular mass, melting point, boiling point, molecular volume, viscosity, and elastity for each of the chemical compound by using the profit. The diagram below shows the property constant for flexible alcohol compound. This property constant is used to find out which alcohol can be selected as the main ingredient for the hand sanitizer. So, after we set up the constant for the that 16 chemical compound, it was found out that ethanol, isopropanol, and 1-propanol are the only flexible alcohol molecule from the listed property constant. Later, we do justification from this alcohol. It was found out that boiling point of 1-propanol is slightly higher than that of ethanol and isopropanol. So its evaporation rate is slightly longer than that of ethanol and isopropanol. So we can remove the 1-propanol from our selection. Next, we look for the viscosity. The viscosity of ethanol is higher than that of isopropanol. The consumer always prefer gel condition than that of film and liquid hand sanitizer, and the viscosity of ethanol is much matched to the consumer need, which is gel condition. So at last we select the ethanol as the best alcohol candidate for the hand sanitizer product design. That's all from me. Thank you.
Hi everyone, my name is Logiswaran. So I'm going to discuss about task 3, which is property model for mixture. So first let's look at the property model to determine viscosity of liquid mixture. So this property model used to determine the viscosity of the mixture by calculation using third roots. This is originally from a journal by Chang and Perlstein, 1987. So the model will look like u to the power of 1 over 3 equals to x1, u1 to the power of 1 over 3 plus x2 times with u2 to the power of 1 over 3, where u is equals to viscosity of mixture and x1 and x2 will represent the mass or molar fraction of liquid 1 and liquid 2 respectively, and u1 and u2 is represent viscosity of liquid 1 and liquid 2. So next is property model to determine vapor pressure of ideal mixture. So this is determined from Raoult's law. Raoult's law states that the partial vapor pressure of a component is a mixture is equal to the vapor pressure of pure component at that temperature multiplied by its mole fraction in the mixture. For a binary mixture, PA equals to XA times PA naught, PB equals to XB times PB naught. The total vapor pressure of the mixture is equal to the sum of the individual partial pressures. Total vapor pressures PT equals to PA plus PB. So next is property model to determine density of the liquid mixture. So this is a proposed model incorporated with mixing rule to determine the density of liquid mixture. So 1 over density of the mixture is equals to mass fraction of liquid 1 over density of liquid 1 plus mass fraction of liquid 2 over mass density of liquid 2. So these are the set of combination of ethanol with moisturizer that we're going to run in this model properties. So set 1 is ethanol plus glycerol, set 2 is ethanol plus propylene glycol, set 3 is ethanol and sodium lactate, and set 4 is ethanol and dipropylene glycol. So the optimum composition for all the mixture were calculated using Microsoft Excel solver. So from their calculation, we have figured out the optimum composition for all mixture and the calculated property. And this has been tabulated as shown below. So for the set 1, the optimum composition for ethanol is 0.9583, which results in 2500 Cp and density of 0.8019 and vapor pressure of 46.6561, and so on for other sets also. So according to our target properties, set 1 complies all the target properties. So we choose set 1, which is ethanol plus glycerol combination for our hand sanitizer production. So this will be the finalized formulation of the hand sanitizer product. So we used 83.3% of ethanol, 1.5% of glycerol, 4.2% of hydrogen peroxide, 5.2% of water, and 0.8% of lavender oil. So the total viscosity of this hand sanitizer is 0.022, and the density of the hand sanitizer is 864.17 kg per meter cube, and the vapor pressure of this hand sanitizer is 76.9 millimeter cube. That's all from me. And next.
Hello, my name is Divya. Now I'm going to explain about the decision making. Based on the table that we have shown, it can be concluded that the cost for raw ingredients for 1 unit of a hand sanitizer costs about 49 cents, with a profit margin of at least 400 that has been expected. Thus, we have decided that the selling price for 150 ml of hand sanitizer is 3 ringgit in total. Okay, based on this table, we can see that the IRR value has been solved using the Excel solver. The result we have got is 24%, that is more than the bank interest rate, which is the 5%. Thus, this project can be carried out. Okay, from this graph, it can be seen that the payback period, it falls between 1.5 and also 2. So the expected 2.02 years has been justified. Okay, so now we are looking into the design of our hand sanitizer bottles. We chose the mainstream medical color, which is the blue and white color. When it comes to a product packaging, blue is known as one of the safest color to use, irrespective of the age or also gender of the potential customer. Not only that, we have used polyethylene terephthalate, known as the PET plastic, in the making of our cap and also hand sanitizer bottle, because it is known to be a strong, break resistant, and also can be as clear as the glass and also jar bottles. Okay, now let's move on to task 5, sustainability consideration. Okay, there are three important factors, which is the social, environmental, and economical sustainability. In terms of social, fragrance they are often used to hide the phthalates as an ingredient. But in our product, we are using a lavender oil, which is nature friendly, and it is also shown to be non-irritant and suitable for sensitive skins. In environmental sustainability, our hand sanitizer bottles are made up of a recyclable material, and also in economical sustainability, we provide the best formulation with only a low cost of 3 ringgit per 50 ml of sanitizer bottle. Okay, there are two goals that we are focusing. The first one will be goal number 6, which includes a clean water and sanitization. The usage of ingredients such as a lavender oil that will not pollute the water source because it comes from a natural source. And also we are giving discounts for our hand sanitizers if the customers are returning our used hand sanitizer bottle. So we can recycle them and reduce the plastic wastage that will eventually go to the ocean and seas. In terms of a sustainability development goal number 12, we are responsible consumption and production in a sustainable development, and also our products are manufactured using a biodegradable and recyclable, environment friendly, which is the polyethylene terephthalate. Okay, in terms of sustainability market, our mission is that all our hand sanitizers are sustainable by 2030. So we are making our small bottles out of things that we can grow again and also recycle. This is one of the main attraction that we are giving to our customers. Not only that, we also reduce the burden of the customers by asking them to return the used bottles before they are buying the new one. By using this, we are not only encouraging our customers to recycle materials, but also we are helping in producing a better environment with less wastage. That's all from us. Thank you.